Hi, my name is Noah Gift. We're going to talk about data pipelines today. It's one of the things that you really sometimes don't think about when you're building a data engineering project. Maybe you're focused on collecting the data or transforming the data or putting it into a database. But then there's this problem that crops up is, okay, great, I did it once. How do I do this every single day? And how do I do it in a repeatable fashion? And also, how do I let other people on my team use the same software? So really, it's a process that needs to be very thoughtful, and it also needs to be architected in a way that is easy to debug, and also that it's going to be reliable. And so there's a few different ways that we can think about these data pipelines. One is that they're low code, they're very simple and lightweight, and then all the way at the extreme, you have data pipeline technologies that were developed at huge startups or unicorn companies, and they've developed their own methodology, open sourced it, and put it into the wild. So there's a wide spectrum of what you need to do when you're considering how to build a data pipeline. And we'll talk about how you can use both approaches and how to reason between those different styles of data pipelines. Okay, let's go ahead and get started. Let's talk through this concept of a data pipeline. At a high level, what is a data pipeline? Well, it's a series of steps. You're going to automate maybe the collection of data, the transformation of data, the loading of data. And typically in step 2 here, this transportation of data would go to a destination that would include things like a database, maybe a data lake, which would be, in the case of Amazon, S3 storage. And then later you're going to do something with it, right? You would put it into feature store, maybe you would manipulate it a little bit, maybe drop some columns. And finally, when you're done doing those steps, you want that final destination to be a high quality source. And we'll get into some of those sources in a second. So let's take a look at maybe the next thing here on the list, which is what are the types that you can think of in terms of data pipelines. A couple different ways to consider would be that you have simple, right? And typically this would be batch. And really the most simple way you could do a data pipeline would be to have a Linux machine that has a cron job and it does something at an hourly basis or a daily basis. Maybe it talks to a database and puts the queries from that database into a report. Also, you can use higher level tools or cloud native tools like Amazon Athena, and that could actually transform that data and put it into, let's say, a data lake or allow you to do serverless data engineering. There's also batch jobs. The AWS batch system has the ability to do periodic problems as well by spinning up a cluster of machines. The harder one is this real-time, and there are platforms that do this. There's Databricks, which is has Spark, which has real-time capabilities. Amazon EMR, which also has those capabilities. And then there are streaming services that are cloud native like Kinesis, and then Kafka would be an example of something that could also be an open source version that would be somewhat equivalent to Kinesis. Now let's move on to what I would consider just more of a thought experiment here about data pipelines. This is not an exhaustive list by any means, but one way to consider data pipelines is to think about this concept of lightweight to medium to heavyweight. And as I mentioned earlier, cron is a great example of this, where in a cron job, you can run it every hour, you can run it every day, you can run it every month, runs on a Linux machine. There's really not much to do. It's just a script that runs. And in fact, that could be very suitable for a small company or a startup that doesn't want to spend a lot of money on sophisticated systems. And also, it would be really easy to debug. Now, if you're using a cloud platform, there are a lot of advantages to using things like AWS Lambda or step functions as well. And what's nice about those serverless techniques is that they can be event driven. So they can be called in response to maybe an image that's placed in a bucket, or maybe a website that is scraped, it's put into a bucket, and then you do something to it. And these are really lightweight systems, and we'll talk about a few of those in a second. The medium weight would be non-cloud. And one of the ways that you could do a non-cloud data pipeline using legacy technology would be Jenkins. In fact, I've done this before. I've created very sophisticated pipelines that did many different things for data engineering before there was a lot of these open source tools available like Airflow. And Jenkins is a build server, but it can just do scripts, right? So you can use it to generically orchestrate jobs. There also are cloud versions of these technologies. I would say AWS Step Function is a really good example of an orchestration framework where you can easily get results, but it's not necessarily hard to get started. Athena and Glue, these are serverless techniques. Glue is something that can introspect a data source and collect that data for you, which is really helpful. And then there's Lambda events that can talk to things like SQS. So you can tie together Lambda with more sophisticated tools like a queue, and this queue is very high throughput. Essentially, you can't give it more traffic than it can take, so you can build on these really powerful primitives. Then we get into the heavyweight systems here, and this is where these startup unicorn companies have developed a lot of technologies like Airflow, Kubeflow, Kafka, these kind of technologies here, and these are really sophisticated and powerful, but they're also tied in a sense to a really sophisticated startup that has the resources to manage this. The other alternative would be to use a cloud platform like Databricks, where you get a support contract, you call up Databricks and say, hey, my cluster's not working. It's a Spark-based solution. SageMaker is something that Amazon makes, same thing. All the cloud platforms have some kind of data pipeline. Azure has Data Factory, Google has Dataproc, AWS has their own data pipeline system. There's also EMR, there's Data Wrangler. There's lots of these different tools here that can help you build out different heavyweight data pipelines. Now, finally, if we look in terms of destinations here, one of the things to consider is where are you going to put this data? A lot of times you will put this data into a data lake, and the reason for this is you can put unstructured, structured data, binary data, and data lakes have infinite CPU and storage and disk I/O. And this is really the advantage of this, is it's really a place that can handle the load you give to it, and then you can build things on top. Another destination could be a data warehouse. So this could be a column-based database like Redshift, and you could build BI dashboards on top using things like Tableau or QuickSight. There's also a feature store. And so a feature store allows you to build machine learning pipelines very easily on these technologies. And then there's also maybe like a database, just a regular SQL database, or even a key value database like a DynamoDB or MongoDB database, where you can maybe do things with customer data. So those are just a few things to consider when you're building a data pipeline from scratch. So let's take a look here at what I would consider a lightweight data pipeline. This project, AWS Lambda, has got a good picture of what I would consider a serverless AI data engineering pipeline. We've got a timer here. This timer calls this Lambda function. It reads from a DynamoDB database, which is really just key value database. It pulls that data, pushes it into SQS. SQS has a Lambda that's listening to it, and it gets triggered and called every single time you put a message in. And then we do some scraping and then do natural language processing and put it into S3. And this is, I think, a really good pattern to use if you were going to build out a more sophisticated data engineering pipeline using cloud-based tools. Now, another level above that would be something like this, and you can see this project, which is AWS Step Functions, is also has some of those same capabilities. And if we take a look at this, you can see here that the overall idea is you chain together AWS Lambdas into input of one feed into another. Here we go. I have first step, I enter a phrase. Second step, I do a sentiment analysis. Third step, I score a phrase, right? And I've got this data pipeline created here. And then later, if I wanted to, I can invoke these, right? By using the command line, I can say AWS Step Functions, list state machines, and then I can go through here and execute that step function. So pretty powerful system here that you can build by using step functions, and then you can call them later via the AWS command line tools. Now, what about if I want to do a big heavyweight system? Well, let's go ahead and take a look at something called AWS Academy. It comes with your education tools for your university. And there's a lab here that I'm going to run that says query data in S3 with Amazon Athena and Glue. And you can see that what Glue does is it integrates with Athena It integrates with Redshift Spectrum and with EMR. Those are really the main tools. This is a serverless data processing pipeline. This is a data warehouse, and this is a MapReduce system. So in this particular lab, Glue is going to crawl a data source. It's going to grab the tables and the schema, and then we're going to query this data in S3 and build a catalog with it. So I've already started this lab. You can see it right here. You can see it's been running for a bit, and I can even look at the details and see those details here. And this is one of the nice things about the AWS Academy resources that you can get through your university. So I'm going to scroll this to the side like this so we can look at both. And then I'm going to click on AWS, and this will pop open an AWS tab here for me to manipulate. And so what I'll do is I'll just toggle back and forth between these two projects, and we'll follow the instructions. So first thing it says is start the lab. We've done that. So here's the scenario. You're a data analyst who works for a development agency, and you want to look at drought relief, and you want to look at weather patterns from 1950. We've got this global weather data in S3 already. And so here we go. Here's the solution. We're going to have an IAM user. That this IAM user is going to interact with Glue and S3 and Athena. So the first thing we're going to do is we're going to create a crawler for that data set. And in order to do that, we're going to have to go to Glue. So let's go ahead and go to Glue here, and we will search for services here and type in AWS Glue. And then once we're here, we'll choose get started here. So let's go ahead and maybe scroll this over a little bit right here. And you can say add table using crawler. There we go. And then we're going to put in weather right here. So let's see if we can maybe move this a little over like that. And then we'll keep this in the foreground here. Perfect. So we'll say weather, next, and then we're going to say for data sources, we're going to say the crawler will be data stores, and then we're also going to say next here, and we're going to choose S3 location. So we'll go here, and we'll say add crawl data in another account. There we go. And we'll put it right there. And then we'll say next. And then we don't want to do another data store. We'll go ahead and just do this. Make this a little bit smaller. And then what we'll do is we'll choose an existing IAM role. And this will allow us to have the privileges to do this. Next. And then we want to say run on demand. Next. And then for database name, we're going to put in, we're going to say add database, and we'll put in weather data. There we go. And we'll say create, and then we'll say next, and then we'll say finish. Okay, great. We got this thing cooking here. It's ready to go. Now the next thing that we're going to do is we're going to click this, and we're going to select run crawler. And then this will go through here, and it'll take about a minute, and it will go through and add this crawler. Okay, let's go ahead and see what the crawler created. And if we click on table here, there we go. We see that this table has been created. And notice here that there's a bunch of metadata, right? So we have the parameters here, the properties, which is really the count of how many different records there are. There's a lot of records here, the average size, and then also the column names here, and then the data types. So we've got a lot of information inside this database. And what we can do next here is scroll down here and edit the schema. And so what we'll do is we will go into the upper right-hand corner and say edit schema. And we're going to change them by entering these new names. So notice these are all unnamed names here. And so what we want to do is we want to change these and do them one by one. So we'll change this one, call this one station, and then we'll go through here and we'll say date. and then we'll do type, and then we'll do observation, and then we'll do imflag for this, and then we'll do sflag. Let's see, S flag, there we go. Q flag, and then time. Perfect. All right, now that we've got that, we'll go ahead and say save. And then we're going to query the table using AWS Glue data catalog. And so what we're going to do next here, we're going to go to choose a table, and then we're going to select this box, and then we're going to say action, and we're going to say view data. And we're going to go here and click this button, preview data. And so what's nice about this is that we can actually go to the services and we want to choose S3. And so we're going to you'll see the following message. You must specify a bucket. On the services menu, choose S3. So we'll choose S3 here. There we go. And then what we will do is we can select the bucket name here, which is this bucket, and we want to copy the bucket ARN. And so in order to do that, we can say here, access point, and we can go to, let's go to the bucket name buckets, click on this, copy ARN. That's what we want to click. And now we're going to go to Athena here, and we're going to set up a query result location in S3. So we'll go ahead and do that. So we'll say manage, and we'll do this. We'll put this in, and then from here, enter the name of the bucket, and let's just make sure at the very beginning the bucket has to be terminated with a slash. And then if we do a Control A, we have to put in S3 here. So the name of the bucket is a long string of characters. Before the name of the bucket, make sure you do S3. So we'll say S3, and we'll say save. There we go. And then from the list of databases, choose the CSV table. So let's go back to the console here, to the editor. There we go, AWS weather data. And then we're going to choose this table. And we're going to say, choose these three dots, and we're going to say preview table. The bucket is not valid, so I think we messed up the bucket name here, so let's go ahead and fix this. And I believe it could be that it's this. This might be the issue. If not, I can double check the bucket name here. Let's see if we can open that bucket up. Yeah, that looks like that is the bucket name. Okay, so that was probably what the issue was. We go ahead and select this, and we say here, and we see preview table. There we go. Now we can preview the table, and now we're able to collect that data. Now, if we scroll down here, we can create a table for data after 1950. So we're going to go ahead and copy this, but we're going to put our own bucket name inside of here. So we're going to do a query here, and we need to remember that bucket name, which is always hard to find. Let's go ahead and put this bucket name inside, and then from here we'll put this inside. So we'll say S3, your bucket. There we go. Okay, let's go ahead and say run, and now we're able to basically create this different view of the data And you can notice that it's scanning a huge quantity of data, right? It's scanned about 80 gigabytes of data here. So this is a true big data job. And then once this table has been created, it should populate over here. Okay, notice now it created it here. Now I can select this and I can just say preview table, and then notice that it now lets me do queries on different aspects of the data. So I can go through here as well and make a new query here. Let's just make a new one, populate this inside, and then look, it's going to say I want to basically run a query from the selected data. And then now we can go to this Tmax view, and we can actually go through here and we can say preview the view, right? So we're doing lots of subqueries on a huge data set here. And look, this is much smaller, right? Because it's only 600 megabytes here. And then if I wanted to, I could do other queries here. Here's one more. I can go through here and I can run yet one more. So let's go ahead and do this query. And we should see a table of data results from 1950 through 2018. Okay, well, we can let that thing finish on its own here. So in a nutshell, just to kind of bring things back here, really what's neat about this, and we go ahead and we say in lab, that we're able to use this big data system here to query a very large amount of data and then put it into view so that we can do things with it and build business intelligence and build data science solutions with it. And so that's really the idea, is to have this glue which inspects the schema, manipulates it, lets us transform it, and then we use Athena to query it. And notice that we didn't have to spin up any servers at all, which was one of the powerful things. So now let's go ahead and install Jenkins. So I'm going to go to Cloud9. I'm going to create a quick environment here. We'll just call this Jenkins. There we go. And we'll say next step. Leave everything default here, and then say create environment. Okay, now that we got this running here, notice I'm at the Jenkins page, and I'm going to download a generic package, which is a WAR file. I'm going to right click on it, say copy link. And one thing we want to double check is the Java version. So we'll say Java-version. And notice we have 11. I think that's going to work for us. So I'm going to go next here to wget, download that file. Now, in order to run it, it's actually pretty straightforward. If we go to this page, first let's let this thing download. There we go. Got this thing running. Perfect. And notice that it just puts a WAR file right here. And if we look at the size of this, it is 69 megabytes. And if we go to the instructions about how to run it, it's pretty straightforward. We just do this. We just say Java Jenkins WAR file, and it'll open up a localhost 8080. There we go. And if we get lucky, everything will just work. And it appears to be working. It should give us a password here as well in a second that we can use to log into it. Now, here comes one of the issues with an environment like Cloud9 is, how do you actually log into this, because it's in a preview mode here, and there's a couple ways to figure this out. Again, this is the password here, is what we can do. If we go to preview, this might work. Preview running application. Oh, let's not get into that. It's too tricky to figure it out. Instead, what I'm going to do is I'm going to go to my AWS account and I'm going to open up this port. So I'm going to go to console. We'll go to EC2, find this out, go find the machine that's running. There is right here, this Jenkins machine. And if I scroll up, or I scroll to the instance, we can find the security group. There we go. Here's our security group. And we can just edit the security group by creating an inbound rule. And we want to edit it and add one rule that says custom, and it's going to be port 8080. And we want everybody to access this because this is a demo. We'll go ahead and save those rules. Now I can go here and I just need to find out what my IP address is of this machine. So, I mean, an easy way to do this would be just to go back to my instance, click on it, and if I look at the instance ID, it'll tell me. So we can just click on this right here. So we can go to this IP address and then put 8080. And Jenkins is running. Now we need to put in that initial password, which should be in this console. All right, here we go. We're back at this terminal here. Notice that this is the password. And if I just put this in, we can do this. And that will let us select install plugins. That'll take a second here. And while that's installing here, you can see that this is just a generic tool that is designed for doing continuous integration and continuous delivery, but it also works well for running any kind of a job. And so that's one of the nice things about Jenkins. It's free, it's open source. It works very well with building systems that run any kind of a job that you want to run. And it's very straightforward to prototype it on the AWS platform. So once this thing is woken up here, you can see here, I can just put in some defaults here. Don't use this. There we go. Just put in some garbage stuff here and continue. And then we'll just say save and finish. And there we go. We can just start using Jenkins. Now, at a high level, really, to just run anything, you just say create a job. Go here and you say hi, hello, and freestyle project. Say OK. And the simplest kind of hello world job to create would be to go inside of here, configure this, and just put a build step. And this build step can literally be ls-l, right? It can just be anything. So this could be talk to the database and put the data somewhere. We say save. Again here, we say build now. And then it'll actually show us the output of the build once it's been complete. I don't know if I actually selected it. There we go, build scheduled. And if we go back here, you can see that this is the console output. There we go, finished, right, hello world. So pretty straightforward to set up Jenkins, play around with it. This could also be a great lightweight tool for you to use for data pipelines.